Hey everyone, welcome to this session. Our topic is extractions of metals. We are still discussing about the properties of metals. We discussed some of them in our past video. We discussed the oxidation state and releasing in our past video. So today, let's move on to the activity of these metals. Specifically, we'll be discussing the reactivity series of metals. So this reactivity is just one of the property of metals whereby it describes the ability of metals to react and combine with the other elements. Now, what do we mean when we say reactivity series? This reactivity series of metals simply refers to the arranging or listing of the metals in order of the reactivity. So it's just the arrangement of all the metals in accordance to their reactivity strength. This means that the ones that are stronger in terms of the reactivity will be grouped together, and the weaker ones will be grouped together. So this reactivity series are obtained by the consideration of the action of the air, water, and the acids on the metals, and how easily the oxides of these metals can be reduced. So we obtain the activity series of various metals simply by considering the various factors such as this, the first one, that the action of these metals towards air, water, and acids will determine their arrangement or listing within the table or within the list, and how these metals they react, and how easily their oxides they can be reduced. Moving on, let's see this reactivity series of metals. So consider the table of reactivity series below. So here there are various elements that are grouped together. The ones at the top are the ones that are considered very reactive, and they are the ones that least in reactivity. Then the ones at the bottom are the ones that are least reactive. So in our first group at the top, we have this potassium, sodium, calcium, magnesium, and aluminium. So these are the first ones that are very reactive, and they are never found as free elements, and they can be simply extracted by electrolysis, which is the most powerful way of extracting the metals. Moving on, the second group consists of these zinc, iron, and lead. These are the moderate reactive elements or metals. They are found as oxides, carbonates, and also sulfides. They can be extracted by the reaction with the carbon or carbon monoxide. Then the last group is this consists of copper, mercury, silver, and gold. So these the ones that are found at the bottom, they are not very reactive, and they may be found in nature as free elements. So they exist uh, themselves. They are always free elements, less than compared to the ones that are at the top, which are very reactive, so which they cannot exist free, or they cannot be found as free elements. So these the ones that are not reactive, they can be found freely, and they can be found in nature as well as that way free elements. They are known for a very long time, since they can be extracted within our Earth's surface. Moving on, so from the table which we've discussed, the oxides of the first group of the five elements that we've seen in the first group, they cannot be reduced by carbon. And those of the second group of the three metals, they react with acids, displacing the hydrogen. While the third and the last group comprises of the least reactive metals, which we've already said those elements. So in the table above, the metals are arranged in order of the reactivity series. So it indicates the inverse order in which the elements were isolated Thus, the metals are low in series such as the gold, silver, and lead have been known as since the early times. The metals high in the series proved very difficult to isolate since they are very reactive and they could not be found as free elements. Now, it was by Davis' work on electrolysis that led to the isolation of the potassium, sodium, calcium, magnesium, and aluminum over a period of years from 1807. Now, when Davis isolated the potassium and sodium, it was about 1850. Then, when also aluminum was isolated. So, the most reactive metals that are found within the first group. They've been isolated and been found as themselves during the 1850s and the 1807 by the Dave's work. Now, the metals low down in the series are frequently found as the free elements, although they may also be obtained from ores because the amounts found as the free metal are not sufficient for the industrial processes or various industrial purposes. Gold, however, the last element of the series is found and mined almost entirely as the free element. Generally, uh, in these relative and creative metals that we find them the most uses for iron and copper, for example, can be found in many household and everyday objects. Metals high in the series are more reactive than those lower down. So from there, a metal high up in the seas will displace a metal lower down from the solution of one of its salts. Take an example, iron will displace copper from its salts. As you can see, when there's this reaction, iron plus copper sulfate, the copper will be displaced by the iron, so the copper will remain itself and will result also to iron sulfate, while also zinc and iron will displace hydrogen from the dilute acids such as the dilute hydrochloric acid or dilute sulfuric acid. As you can see in the reaction, zinc plus this hydrochloric acid will displace this zinc will displace the hydrogen and will result to the zinc chloride plus hydrogen gas. And also iron, when it reacts with this uh, dilute sulfuric acid, you result to iron sulfate plus hydrogen gas. Copper has no reaction on either dilute sulfuric acid or dilute hydrochloric acid. So you have to note that. Now with hot concentrated sulfuric acid, uh, the sulfur dioxide is liberated and the copper 2 sulfate is formed. As you can see, a copper plus this hot concentrated sulfuric acid goes out to copper sulfate plus water, then plus sulfur dioxide. So useful things to remember about the reactivity series. So from all those explanations which we've seen above, so here are just few of the useful things to consider or remember about the reactivity series. The first one, that the more reactive the metal, the more compounds it forms. So only copper, silver, and gold are ever found as free elements in the Earth's crust. The other metals are always found as compounds. And the second one, that when a metal reacts, it gives up electrons to form ions. So the more reactive the metal, the more easy it gives up the electrons. The third one, that the more reactive the metal, the more stable its compounds are. The stable means it becomes difficult to break. Take an example, when you heat this is sodium nitrate, you get sodium nitrite. As you can see, in the reaction, this decomposition reaction, the sodium nitrate will decompose to sodium nitrite plus oxygen gas. But copper 2 nitrate breaks down further to oxide, giving off the nitrogen dioxide. As you can see there in the reaction, copper 2 nitrate breaks down to copper oxide plus this nitrogen dioxide plus oxygen gas. The fourth one, that the more reactive the metal, the more difficult it is to extract from its compounds, since the compounds become very stable. For the most reactive metals, as the ones that are found in the first group at the top, you need the toughest method of extraction, that is electrolysis. Now, the less reactive metals have been known and used since the ancient times because they are easiest to extract. You can easily extract them from various mines. And the last not least, if you stand two metals in an electrolyte, join them up with a copper wire, the electrons will flow from the more reactive metal to the less reactive one. So I hope it's clear, guys. Thank you for listening. We've been discussing about the reactivity series of metals. We've seen how metals they are arranged according to their reactivity strength. We've seen how that uh, it, it differs them, or it just differentiates them from the reaction with the other compounds. Thank you.